Okay, so what I want to talk about now for the next half an hour or so is SE 3.0. Okay, so what exactly we mean by SE 3.0 and where do we see software engineering itself changes? So remember, so there's software 1, 2, 3, 4, 5, okay? But to make that type of software, you need a new type of process, which we call SE 3.0. Okay? So overview is, we want to think of what it means to rethink software, okay? So the software errors themselves, the software engineering errors, and then how we can get there, the whole technology stack that's involved to do that. So that's the question I was asked earlier today is, what would compiler look like, for example, in this new world, and where we are today, where the field is, and some conclusions. Okay. Okay. So anybody know what the picture in the background of this is? Anybody know? Yeah, go ahead. Yeah. So Sputnik. So the U.S. never expected that the Russians could actually put something in space. They put something in space, and since then, the U.S. woke up and realized, well, other people can do cool stuff, okay? So, and that is actually one of the big things that really started DARPA, right? So the idea is they want to avoid what we say technological surprises, right? To do that, really, you need to have this innovation. You need to think where you're actually doing very high-risk things with the potential for game-changing, high-return impacts. So this vision of SE 3.0 that we talk about today is more about what happens if we actually say, you know what, we're not going to do innovations here, we're not going to do innovations here, but we're going to actually rethink the whole thing end to end. What would that be involved? And then how we can push the community to go there. So this chart, and to motivate this, I want to show this chart here. So this chart shows all the top, the world records that have been broken on every year in swimming, okay? Since the beginning of kind of time track, record keeping, all the way to early, 2020, the 2020s. And you can see here there's two spikes. There's a spike here, and there's a spike here. Anybody can guess what that spike is here? Yeah, some technology, something happened that swimmers had access to, and because of that, suddenly a lot of people could break records. So I always ask that question, and people always tell me that swimming suit, but people still wear swimming suits, okay? So the assumption here is before that, people swam naked, okay? And after swimming suits, a lot of world records. No, so that's not the one. There's not much left, so there's swimming suits, there's this, and there's this, okay? So, sorry? Goggles. Okay? So goggles were actually invented, okay? And became common use, so a lot of world records were broken at that time. So then there's the other one here. Anybody can guess what that's the other one? What that one happened? Data analytics started? No. It's related to him. Okay? So it's actually what's called the laser racer suit, okay? So that suit was designed in collaboration with NASA. That suit today is actually, it's illegal to wear it in Olympics, in any type of competitive swimming. Okay, it's kind of inspired from the skin of a shark. Okay, it actually is it compresses your body. And this was the Beijing Olympics where all these records were broken. And that's why this year in the Olympics, when a lot of these prior records were broken, people were saying, oh, people are doing doping. Because actually, first, the Olympic pool in Paris was too shallow, so usually you can't break records in a shallow pool. There's too much water, push them back, right? And second, a lot of them were broken when people were wearing these super suits, okay? So these are kind of two big technologies that kind of happen, and you could see their impact, right? Okay. Now I want to talk about another one, okay? So in the old days when people used to do the high jump, they used to approach it what's called the straddle way, okay? So you basically run and you jump forward, okay? Then Forsberg came in and he said, no, I'm actually gonna jump backwards, okay? This was actually crazy because at that time, not always they actually had that pillow there did not always exist, okay? So here is somebody changed the process, totally rethought the process. Okay? So let's now think of that and where we are in software engineering, right? So software engineering 1.0, code was the first thing. And we had tools, a lot of static analysis, that kind of tools. And we are actually still supporting what we call the traditional software engineering process. So requirements, you think about like waterfall as the simplest one. So requirements, design, architecture, design, code testing, okay? So that was the goggle time. Then in software engineering 2.0, which is something that we started with MSR many years ago, which is how can we bring AI? We're not changing how people build software. We're still taking anything you were doing and we're making it better with AI, okay? We're making it faster. The million-dollar question now is, what happens if we totally rethink software and software engineering and now think of how AI can do things that we can do, right? So, for example, we know that N+1 programming, where you actually have multiple, you assign different teams to implement the same software, will lead to better code, okay? But N+1 programming is insanely expensive. Instead of building the software once, you build it 4 or 5 times, and then after that, you somehow get them to all vote, all the implementations to vote, and then you decide what to do. That's done, for example, for train systems, high safety systems. But now if that type of things could be done with AI and it could be done very cheaply, maybe anybody could do that, N+1 programming today. Okay? So now we want to move from what we call data-driven models, that are very expensive, to what we call efficient, knowledge-driven models. So this is kind of like the vision of software 3.0, okay? There's a paper that we have put on archive on that. Okay? And why this is inspired, a lot of this is inspired actually, having talking to Jack as well over the last year about a lot of, he's really inspired by chess, okay? And he got me convinced about chess. Chess is the future, okay? Because you think about it, at one time when chess, and this is from Jack, right? At one time when chess has been solved, okay? Chess, according to AI, is no longer a problem. Okay, so think about it now. Can we get to chess? Okay, that's one. And second, if you think that AI has solved chess, chess is still around. And it's at the most active time ever, right? So this is a very important game. So, this was a Deep Blue, okay? Playing, the world expert in chess. And the idea here was this was sort of NBC, we humans are trying to figure out our next move. This was one of the biggest things. So the thing is, as Jack said, he lost. And then after that, he had the other game. He created this new competition where world experts can compete against any one of us, but everybody brings their AI. And to the surprise, any one of us with an AI was able to win. Okay? Well, at least some people that are not expert were able to win, right? And this is the code. So Gary's a Russian, so you should really read this way. It's easier, okay? But I'm coding it as he said, right? The point here is that a weak human player plus a machine plus a better process is superior than a very powerful machine, okay? Which we already know that. But what's really surprising, it is even more better than having a stronger world chess experts, but they're still doing the old way to play chess, okay? So this is where we are today, right? We're giving our top developers these toolings, but they're still thinking of the same way to develop software. Can we change that, right? Now, why we think this is important, and why do you think this is actually going to succeed? So for Go, what happened is Go now, a lot of players use Go, use AI when they're playing Go, and recent studies have analyzed the complexity of the moves that Go players do, and how it's becoming more complex and the complexity of that. And what they notice is AI is making human developers, human players become even better players. Okay, so the complexity of their game is becoming much higher. It's taking it to the next level, right? So it's not really the end of development, it's actually the next big thing. So now let's go back to our software, right? So what is software? So somewhere in the middle, okay, we started thinking that software engineering is about making code. Code was never the end. Okay? Code was a mean to the end. And if you think of that, that means really why are we even talking about code altogether? And anything, at least in my view, that we're in the SE 3.0 view is, if you're helping people coding, you're just helping them doing the wrong thing. Okay? Same way when, when Tesla had their models and they were doing all these models to figure out, object detection, to know that there's a light, know there's a person crossing, to know there's a kid. And they said, no, why are we doing that? We really don't care. With our final solution, the thing we want to solve is whether the car needs to stop or go. I don't care about everything in the middle. Can I just get a model where I give it all the freedom to explore and give me back the answer? Okay? So really what it is that intent is what matters the most. And if you today have ever used ChatGPT or any type of these things, what you will notice is, for the first time, we've always been said, oh, wouldn't it be nice if developers tell us what was on their mind? They are writing to the chat, to the foundational models, the GPTs, telling them, oh, can you do this, can you do that? But then the worst thing is what they're doing is, either they will remove these things later on, because you feel like this is like my rough work, right? Or if they don't remove them, we're not archiving them. We're still archiving the code. But in reality, imagine if you're maintaining a piece of code, that's assuming you're still in the even maintenance of code at all, right? You come back and you look there and you see the discussions. You kind of jump back in time to that moment where this code was being developed. You know what was going in the developer's mind. There was another 1 or 2 AI agents working with them. So you kind of transfer back in time, sit in that meeting room where that piece of code was being developed, and you can start asking questions. Hey, what were you thinking about that? What was that? Oh, and then you say, oh, that's a wrong assumption. Okay, now, knowing everything you know, I'm going to update your assumption and give me a new updated piece of code. But none of that is available today because we're only focusing on prompting in and out, and the code is the thing we're archiving. Instead, it's really the intent that needs to be archived, right? So, we want to rethink the whole stack, right? This idea of teammates.next, IDE.next, compiler.next, runtime.next, and FM.next, so foundational models.next. Now, when I talk about the FM Arts platform, as part of that, to enable all of this, we had to rethink, different programming models, all that kind of stuff, right? Okay, how to make sure the things are observable, verifiable, multi-agent frameworks. So that's, for me right now, you can think of what I presented earlier today is the kind of the pipes. So we put the pipes, and now we're ready to kind of go to the next stage, which is really building the real way to develop software, or at least the future way to develop software. So what I'm going to be walking through is kind of walking through all of these, giving you some hints on how it is. There's a lot of things that still need to be done, okay? However, in the next couple weeks, we have implemented a prototype for everything in here. So we know that this would work end to end. The only thing is just, there is so much to be done, right? This is not something that one person can do. Okay, so as I said, the biggest problem with software development is the human, unfortunately. Okay, humans, we cannot speed them up. They're just not that smart. Okay, so the question right now is, if you think a bit deeper, no project ever has failed because developers couldn't code fast enough. So so speeding up the development speed is not the biggest reason projects fails is there's misalignment, right? So the customer wants this, customer talks to the requirement engineer, and then from there, and so on, something gets dropped in the middle, or the requirement engineer doesn't realize that this is needed. So the biggest challenge today is that intent alignment is probably the most important thing. Okay? Making sure that that you can actually get exactly what the customer wants. You're able to project and realize, what they want is not really what they really want. All these things, and a lot of the big successes of big projects comes down, you have a good requirement engineer that's at the core of it. Okay? Coding is coding. And really, I would love that all of us, nobody's doing coding. Okay, but this is the core thing. So AI now is so good at coding. And not only that, it could do 500 implementations of the same thing and explore them all, and then come back with suggestions, a summary for me, and then I could say yes or no. Okay? So we have this idea what we call conversational-oriented programming. So the focus now is not on the code. Really, the conversations is the intellectual property. It is really the thing that matters the most, is that discussions going back and forth between you and an AI agent or an AI teammate. Okay? And you have to be careful because today, for example, if you have somebody that joined your team recently and you ask, hey, could you grab me a coffee? Okay? And they go get you a coffee, but it has sugar. Okay? So you're not going to be happy because you don't like sugar, okay? But you will forgive them because the first time it's okay. Okay? But if they do it again, you're kind of going to be annoyed, okay? So that's the first thing. It's just like the way we interact with humans is we actually have forgiveness. And quite frankly, the average intelligence of a human is quite low. And foundation models have exceeded that today for many cases, okay? So but we are used to software that if you tell it to do something, it always comes back correct. But imagine now if you say, you know what, I'm willing to forgive you the same way I'm willing to forgive a human, okay? So we're willing to forgive humans when they do mistakes, as long as they learn, okay? The second thing, we're okay if they ask us questions as long as not dumb questions, or something I told you before. So if your teammates can do these two things, learn over time and have a better context when they ask you. So so when we ask somebody to write a piece of code, we don't tell them, could you please make sure it doesn't have bugs in it? It's an assumed thing, right? But as Jack said, these aliens came from a different planet. If you just tell them that, okay, it will actually go for it. And I had examples where we actually have these interactions with ChatGPT, and we show it codes and say, okay, I have this code. I want you to write a function. And any human would actually think, okay, well, if you have this piece of code, I can reuse this code, okay? Then ChatGPT gives me the implementation of my function, but it doesn't use my function. So I say, can you please make sure you reuse the code? It did two things. First, it reused my code, and second, I had a bug in my code. It fixed the bug. Okay? So the point here today, if you didn't tell me what you want, there's a lot of, so sometimes these are not performing well, not because they're not smart, it's just they have a very different value system than what you might have. So a lot of times when you approach them, think of them as, as humans in a way, okay? And second, that their perspective is very different, okay? So code is a new binary. And then now if we keep all the conversations, the beauty is later on, foundational models evolve, we can re-realize the code. And new requirements comes in, we can re-realize the code. It's okay if the GPT actually re-implements all my code, because this is not, do you care that the compiler every time you recompile generates different code? You don't. Because that's a very low level, okay? Now we're not there yet, so we're very far from there. The idea is, well, having multiple AIs discussing together. And the other key thing, so when we wrote this at that time, O1 was not out there, because we're asking it to help developers with very specific tasks, then we have the latency problem, right? So it has to come back to you very fast. But if you start giving it bigger things, you say, hey, implement this library for me and come back tomorrow, that's okay. Right? Because the AI can come back tomorrow, a human team can come back in 6 months or 3 months. So, it speeds up things a lot bit, okay? So this idea is, what is the next hop in programming and IDEs? So we already saw VS Code, we saw Jupyter notebooks coming for computational kind of AI programming editor, and then now this co-programming, what is that type of editor? Okay, so we have already implemented the prototype of that, okay? It uses a theory of mind, which is an idea to kind of walk back and forth with you as a human to try to understand what exactly you want, what the requirements you want. Now, we have used theory of mind as one way. There are many ways to do that. But this is just showing you. So this is an example. So we know it can work. We have prototypes of it working. But there's so much more to do of how an AI and a human work together around the requirement. Okay. So this is an example, I would say, one of the first kind of conversational-oriented programming IDE. Okay. So on this side here, so here is kind of like, the human writes what they want. Okay. And there's a dialogue kind of going back and forth in here. Then once the agent feels they're comfortable, they know what you want, then they generate the requirements and they generate a high-level kind of implementation workflow plan for that. Okay? So that kind of walks you through, and I'm gonna show you as a demo. This is here. It's asking it. So at the bottom here, it will, so it says, okay, I want to receive weekly summarized tech-related news. Okay, great. Let's delve deeper, because that's just very vague requirement at this stage. Okay, so why you want to do this? Okay, so the reasons, I want to stay updated. Okay, now I want to get details. What is the scope? What do you define as tech-related? Okay. So we're going back and forth here, okay. And as it's going, who's gonna be the purpose of the recipient? Only me. How do you want to be generated? They said all the different options I have for you. What are your preferences? So where should I get information from? Now, we will forgive it if we ask it these questions. That dialogue is okay once. But now the next time, I'm going to assume that my AI or my partner knows this, and it could go to the next stage, right? So that just shows, so it goes back and forth here. It tells you exactly what time, it asks you what time you want it to come out. And then soon after it thinks it has enough information, it will output the requirements, and it will output a proposed workflow of implementation. So your goal, your primary objective, the scope, so you can scroll down, it shows you everything there. And then here is how it will go ahead actually about implementing this. Okay, so that just gives you an idea of now, in 2025, which is next year, we're gonna have it where, what we notice is sometimes it doesn't give us what we want, but remember, there's no code. So we want to be able to debug it and understand, okay, why did it went wrong? Okay, so there's this cognition debugging technique, which will be presented on Friday to give you an idea about. So this whole idea of how to debug these systems will be discussed in there. Okay? So what we're really proposing is, this is the classical way. So, human, snail speed, not too smart, using a lot of their brain, okay? We have Copilot helping them to generate code. Then we have the compiler generating the binary. And then we have that loop, the painful loop that most developers really don't enjoy, okay? So we have that going back and forth, right? But instead, if we think of it differently, and we have the human and this agent walking back and forth, so this is a conversational IDE, okay? The agent now is reflecting, is asking a question, asking clarifications, and then the agent just goes, implements hundreds of these things, and comes back with summaries, analysis, asks you, is this good enough? And then you as a human are just reacting to the output, just steering it in the right way, and you're going around this circle, right? So now you as a human are using a lot less of your brain power for this. You're just only focusing on what you care about. And this is why we believe this person here does not have to be as an expert developer as this person here, which is really looking at code and everything. Okay. Good. So this is that, right? Okay. Now the compiler part, what it will be doing is this search thing, right? Okay. If you know something like DSPY, if you know DSPY is out of Stanford, is that Stanford? Yeah. So DSPY is something along that direction, but think of DSPY on steroids, okay? So it's searching for every possible implementation, everything, and it's trying to get you there. Okay. Then the runtime.next, so this is, I was asked earlier, is instead of serving model serving systems, okay, you actually need to serve the whole workflow itself. How do you serve the whole workflow? And what exactly that means? Okay, so we have had work on that, but as well as work from Hong Kong University that tries to do that as well. So how do you actually prioritize that? How do you actually run that? And this is our implementations uses Ray as the backend, kind of the programming model for the whole cluster. Okay. In addition to that, what you have seen is you want to be able to run these things on your phone, right? First, from a privacy point of view. Second, you want when you're actually on a plane, you could still use software. Cannot be once we get on the plane, we can just have to stop use software altogether, okay? Latency. So one of the stuff we've been working on, and we'll be touched on later this week as well, is how do you do this balancing? So don't think of it as a foundational model. It's actually a system, and you have a smaller model and a large model, and they're working together. And the small model is on your phone, and the large model is on the server. And then the small model, when it doesn't know how to do something, we'll send it to the big model. But the biggest innovation here is when the big model solves it, then it gives hints to the small model. Say, hey, let me show you how to do this so next time you don't have to come to me. So now the model, their teacher-student kind of relation happening, and the small model is becoming bigger, bigger, and cooler kind of way, okay? Okay, now, finally is this foundational model, the platform itself, the foundational models. Today, one of the biggest problems when we're building these large language models is we start from all this raw data, okay, and then we generate, the foundational models that are used by the AI teams and so on. But we believe the problem today, if there's a bug, this is just so much garbage in here. It's very hard to actually figure out, what's being taught in here. Instead, one of the visions we're working on, and as well us and the folks at Microsoft, so there's something called the Phi models. So what you do is you take all your data, you almost create a book. Okay? So that's the book for the AI to learn something. Okay? Now once you have that book, so you tell the AI, here's a book how to learn coding. Okay? But models can only use data to be trained. So now you take from that book and say generate millions of examples and exercises based out of that book. Okay? Then you feed all that data to build the models. Okay? Now, later on, you find a bug. Well, the bug will be not in the data, it will be in your book, in your curriculum. So you fix your curriculum, and then you rerun the thing again. Okay? So much smaller data to work with. And now we have, instead we're managing, curriculums, instead of managing just a lot of random data. Okay, so where are we today? So I only have 10 minutes, so we're going to run through this very fast. Okay? The biggest problem today is a lot of people are excited about the number of accepted, suggestions by, for example, code completion. I'm going to go for code completion as an example, okay? The problem today is, yes, it can help you generate code very fast, but the reality, if anybody has developed code, we know that writing the code is not the problem. The problem is that code lasts for 20, 50, 80 years, right? Okay? There's still COBOL code in the world today. Okay? So if you can make it go faster here, but it slows you down, there's a lot of problems in there. So this here, and what makes it even worse is a lot of the foundational models, even if you ask it how knowledgeable you are, so this is work from Prem, recently came out in June this year. So what they ask is, so this is Codex. So Codex only just does token prediction, and GPT 3.5 actually gives you more, complete a lot of things. And then they asked Codex to tell us how confident they are about the recommendation. And then they saw how well that the thing was, and they saw, it's pretty good, right? But when you look at the Codex models or GPT-4, you ask it how confident it is. First it seems to be all over it, it's just almost confident on everything, and even the times that it's not confident, it tells you it's confident, and the times it should be confident, it tells you it's not confident, right? So the thing is it's like having a crazy person working with you, okay? They can't even decide with it, which makes it worse because now you need to use these, okay? Now, when you look at something like human eval, which a lot of people are using today, what you will notice is today, something like human eval first, it's not representative of the type of code that we do, so it's more like lead code, kind of competition type of coding. It's already contaminated, and most foundational models already have it in the data, and it's very sensitive to prompting. So you can just play with the prompt, and you get a 25% improvement by just prompt hacking. Okay. Then you look at something like SweetBench, okay? Well, SweetBench here, 100% of the SweetBench Lite issues impact only a single file, okay? 65% of the Lite actually comes only 2 projects. Both of them are not really represented, both are Python projects. Okay, and 90% of the issues change under 20 lines of code, and 2/3 of them only change 1 file. So it's a very, very small part of really what represents software development. And even when you look at the percentage of accepted suggestions, right, which is a common standard today, you could achieve a 100% if your simple suggestion is adding a semicolon at the end of each line of code. And if you want to even go better, you could you could just enter after that, okay? For good, for good luck, okay? Not really. So you could play these, right? Now there is some nice work today that's trying to kind of do this a bit more in a systematic way, which is really highlighting this compound system, this AIware. So the metric in the middle here, so the percentage of attempts that are accepted, that's kind of similar to what we're doing, right, today. But first is how many times you attempted. What we know today is a lot of the models that doing this kind of helping you when you're coding won't even do an attempt if you're trying to do an edit in the middle of a line. So if there's code here, and you try to kind of do something here, you will not, okay? So that's one, okay? So 30% of actually keystrokes are actually here. You're kind of, this code is already, you're running in the middle, okay? Second thing is the latency. Today, as developers are working, they're moving with their cursor, and every time you give a suggestion, if that suggestion does not come back fast enough, the developer moved on to the next cursor, right? So that's another problem. Okay. And then the size of the suggestions, right? So how big is the suggestions? And then after all of this, you could still take the suggestion and then do a lot of changes to that suggestions, okay? So when you look at a metric, which is, percentage of accepted suggestions, is not really the best way to go about this, okay? Now the problem today is when we look at how developer productivity, well, developer productivity varies quite a bit, right? We can have a 20x difference between a very good developer and a very weak developer, right? And that difference, has been documented in many kind of studies. And the question here is, how do you really help? Is it helping the very junior developers? Is it helping the very senior developers? That is something that, is not very well understood today, okay? And then when you look at between leaders and developers, right? So most leaders, business folks think that AI is going to solve the problems. Whereas when you talk to developers about their problems, they're more about technical debt, inefficient documentation, build process, lack of time for deep work, lack of clear direction. So there's nothing about I cannot code fast enough. Okay, so that's some of the challenges there, right? As I said earlier, no project ever failed because you couldn't code fast enough. Now today in industry, there's many ways that people measure productivity, which is amount of code, deployment frequency, story points per sprint, hours work, how many failure rates. But this study is interesting because it tells you that everybody that's using one of these, half of them are not happy about it. Okay, so it's a big thing. Unfortunately, what's really coming out today is happiness is the metric. The thing is, the problem with happiness is like most drug dealers, okay, measure their success by how happy their customers is, okay? Most smokers are very happy with smoking, okay, and they continue. So the fact you're happy and short-term happiness is not a reflection that you should be doing this, okay? And kids don't do drugs, okay? So I think so I'm gonna show a video here from Volvo, which shows about really some deep views from Volvo, which I think, a lot of people kind of would see there. And then, I want to show that video here.
There's a lot going on in the industry right now. Software is becoming a core value in our business, and that's a big transformation. Our developer community is vast, I'd say. We do anything from embedded software development to full stack web development. We have desktop, iOS, Android, so we have everything basically.
There are plenty of different challenges that I face as a developer. It's sometimes tricky to keep focus. There's a lot of context switching. There's a lot of different tools and different tasks that come at you when you really want to be focusing on just one thing.
On our mission to software excellence, we actually try to put the right tools in the hands of developers and create that space for them to spend more time being creative. Copilot created a lot of buzz, so we were very curious to start evaluating it.
My first reaction to GitHub Copilot was, wow, it does all the boring stuff for me. This is amazing. It teaches me stuff. I learn how to structure functions, and I learn how to structure my code, and it suggests things that I wouldn't come up with myself, which is amazing.
I feel like I'm learning more when I'm using it. It helps me to find new knowledge a lot quicker, and it also helps me to complete tedious, repetitive tasks a lot faster, and I can focus on the work I actually want to be doing.
Today, roughly 40% of our developer community are active on GitHub Copilot, and the signals we're getting are positive. I think we have exciting times ahead. We care about developers and making their lives as good as possible.
Okay. So we got going back to Danny. I think they're just not just monkeys, but they're monkeys that can make us better. Okay, that would be the. And as we can see, even recent studies by GitHub is showing that developers, the problem here is there's an assumption that developers, all they did is coding, and once they were done coding, there was no other things that they could work on. But the reality is developers have so much that they need to do, and they're only focusing on the coding because they cannot have enough time to work on the other things. And what we're seeing is they're actually able to do other things that they wouldn't have touched on before, right? So whether learning, doing more code reviewing, designing better systems and so on. So that effort of the developer's time is being put elsewhere. Okay? So today a lot of extended studies are being done on this now. So it's nice to see that things which are more kind of measurement focused. Okay? At least there's a source graph, study here. So the developers of Cody, the AI coding tool, and they're showing that around 5% of the developers really are using it for what we call AI coding. Most of them are just using it Code Complete ++. Okay. There was a recent study that looked at how much acceleration, and it's around 20% accelerations. Okay, 17% of code tokens are coming from Copilot in that case for that study. But the impact for code health is not promising, right? So there's a 5 times increase in chance of introduced clone code. There's a 25 times increase of introducing vulnerability. Okay? We can fix bugs faster, that's for sure. But if it's putting more bugs, that's a problem, right? So it's really hard to quantify the ROI, but one thing is sure, measuring developer happiness is not the right way, okay? Now, with that in mind, I want to tell you kind of just briefly what we're going to be working on. So we implemented FM Arts 1.0, that one I showed you, they're working right now 1.5. But what we have realized is, in our case, is this SE 2.0 for this world of prompting is not the right way, right? So we were working to try to make it better, give you better tools to prompt better. We recognize that really you should not be prompting at all, and you instead should just fast forward to this SE 3.0 vision, right? Where you're no longer prompting, but you're really talking at a higher level of abstraction, okay? So you should not be writing assembly. That's our perspective on that. And I already showed an example why to give you a hint on that. Now the biggest thing can come out of all of this is that around 20 years ago, Scully from Google stood up at NIPS and said, hey guys, I want to tell you something. Yes, we have a lot of AI systems, but I want to make it very clear. That little black dot is the AI code. There's so much things here happening to make these things happen. Okay? And this picture from 10 years ago, 15 years ago, right, hasn't changed. It just, they have different names today. Okay, whether it's guardrails, curriculum engineering, and so on. Okay, so conclusion, thinking that bigger models, faster models is really the same way people used to think of flops. The business value is not really measurable. Okay, you need to think of a whole AI system perspective and end-to-end value perspective. We need to rethink software engineering and software itself, and prompt engineering or prompt hacking, must die. And that's my main kind of conclusion. So in SE 2.0, we had things where static, impersonal, self-evolving, personalized, code-centering editing to intent-centering conversations. Here we're going from writing rules like if statements to just defining search spaces. And instead of serving models, we try to serve AIware. And then finally, from data-driven models, inefficient models, to knowledge-driven, efficient foundational models. Okay, so that's everything I wanted to say. Questions?
Thank you, Ahmed. Yep, we're running a bit over time, so maybe 1 or 2 questions.
So Ahmed, you talked a lot about SE 3.0 and FMware, like FMArcs, right?
Yeah.
You haven't, I mean, are you going to talk about later, or is it part of the thing where this needs also a different kind of computing device, right? Like, where is all of this going to run? Is it just going to run on, like, are we reimagining what, like, just like iPhones, is there going to be a newer kind of like compute hardware that we want to use that will enable all of this at a consumer level? Like, if you develop FMware, where is it running, and how are we as a consumer using it?
So last month I was in Silicon Valley, and I was attending a talk with Mark Anderson, which is one of the biggest VC capitalists in the Valley, and he was talking about how they look at foundational models, okay, and they look at them as a type of a probabilistic compute unit. So CPU, GPU, NPU, FPU, right? Okay, foundational model processing unit. Okay, which based on that, all the decisions to invest in foundational models are based on that. So you don't invest $1 million, you invest $100 million in a foundational model the same way you invest $100 million in CPU, right? So that's one thing, which is the compute, right? The other thing is the interaction, how you interact with them, right? So we have moved from, we tell the software do something and they have to give it back correct, to this conversational discussion back and forth, right? And then we see more going beyond that, which is, I think, this, neural kind of discussion. So I don't even have to tell you, you can think of what I'm saying, right? So yeah, we need to rethink everything. Even the interaction models and the lower level compute needs to be rethought, yeah. I think there's a question here.
Thank you for this wonderful presentation. My question is, what is the implication of these thoughts on academic curricula, for example, preparing students for next generation software engineering? So do you, like you said, that code is the next binary. So nobody touches binary these days unless a few people. So do you expect that in future computer science students will not write code or will not need to write code or learn code, or what?
Yes, so we need to totally rethink of how we teach computer science, okay? Actually, we need to rethink it even for software 2.0 with foundational models, not even for 3.0, right? Let me put it this way. You already know that people who know how to use Google are more efficient than people that don't know how to use it, okay? So today, the way even if you believe that still prompting is going to exist, you need to teach your students what it means to talk to a foundational model as a partner, right? So these partners are going to be part of your team. How you collaborate with them is going to be a big thing. The dynamics of the teams are going to change, okay? In the old days, when you want to get somebody a promotion, okay, well, you could talk with people that had worked with that person. Do realize that these foundational models are amazing for newcomers in a project. You can bounce ideas with it. You don't have to go to your big boss, so you don't look like, you don't know what you're talking about. So over time, you're going to have much better bonds with these AIs. So now when somebody wants to get you a reference letter, can the AI write you the reference letter? As you become more and more that agent that you work with, like he's like your sidekick, when you move teams, do you have the right to take that agent with you when you move companies? So yeah, the whole, there needs to be a rethink of computer science curriculum as a whole. I have a lot of thoughts, but for a different time. But yes, it's very big.
Yeah, thank you so much.
Okay. With the last one, and then we'll go for a break.
Okay, thank you for your presentation. So you make a bold claim that prompt hacking must die. So actually, the example you show us, the issues of prompt formatting. So I think the main issue may arise from the model pre-training phase. For example, they train with specific data format rather than the other formats. So that's you can only use this same data format to make sense of the high accuracy. So my question is, so how do you tell, okay, this is the prompt hacking or this is the prompt engineering? And if this is a prompt engineering, do you think it still makes sense in the future?
Well, so the thing is, so you write your piece of software, okay? And then you run it on ARM, and the same piece of software runs on Intel, correct? Today. Both of them have different layout, memory layouts, and everything, okay? So the analogy you gave me is the same thing, right? So different hardware, different layouts, different pre-training. So it's the same problem. We solved that by just not even having people go down at that level, okay? So whether you want to call it prompt engineering, prompt hacking, I think prompting as a level of, code layout is what prompt hacking is. How to lay out code and data is the same level of that, okay? And as I said, today even OpenAI is saying, please do not prompt engineer when you're talking with O1. The problem what happens when you prompt engineer in O1, because O1 actually takes it and it does thought thinking. But when you prompt engineer, the problem when you prompt engineer, that simple request becomes this big. And then O1 gets confused about what you really care about because you put so much stuff, right? So it's slowly, I think we're seeing it disappear now. The key point here is it shouldn't be about prompting. It should be really what you want, not how you want it done. Okay? So there will be a different way to code. It's not going to be coding, but it's not going to be down at the level of laying out the bytes on memory kind of thing. Okay?
This gentleman really wanted to ask you a question, so maybe very quickly.
Yeah, I got kind of excited. So I think this presentation is very informative for CS pedagogy, which is the field that I study in. And I'm intending on teaching a class next semester in which students will work with generative AI in various ways. So this is really related to the question that you were asking a couple minutes ago. So as we learned today, the efficacy of conversations for generating what we want is dependent on the specific model being used, kind of following this assembly metaphor you gave earlier, where the model is the particular hardware for the conversational assembly. So given this transferability of conversations between models, what does it look like to have and teach best practices and code smells in conversation-oriented programming? And where do we begin with defining best practices and anti-patterns?
That's a long question, man. If you want to go on a break. I would say look at the, so DSPY, the work done by DSPY is probably the best work at this moment. There is some work by Filippi. He's going to be here later this week. He could talk about that, but he's just trying to rethink. Just give me very high level what you want, and I will take it from there, sit down, and yes, I will come back half a day later, but I will just give you the perfect prompt for your situation. And if there's a new foundation model like 2 days later, no problem. I'll get it done. And if there's another 6 papers that are telling you how to do the best way to prompt, no problem. I'll just recompile. So we want to separate people. It's insane, if you're in, the problem is we were in this field in the middle of it, and literally every week there was like 3 new papers about how to prompt. And we said, we cannot keep up with this, so we need to think of a way to fix that, right? Good, okay, so we'll have a break. Yeah.
Let's thank Ahmed again. Thank you.